All right, so now we move into graphing the functions. Okay, so in the last two videos, we've talked about finding domain, holes, vertical asymptotes, zeros, y-intercepts, and horizontal or slant asymptotes. So now that we have all the important information for our rational functions, now we can graph them. And actually, I'm starting off with a little bit of a complicated one because there are two vertical asymptotes. But the first thing is that you start by graphing all of this information that you have. So the domain, you don't really have to graph. The holes, well, there are none, so you don't have to worry about that. Now, vertical asymptotes. Remember, these are dotted lines representing that there is no way that your graph is going to cross this line. 3 and 2 are not in the domain, so do not cross it. So we will draw vertical lines at x equals 3 and at x equals -2. Okay, so we've got those vertical asymptotes. Got it. All right, now I'm going to jump down to my horizontal asymptote. Okay, so my horizontal asymptote at y equals 0. Okay, now horizontal asymptotes are different than vertical. Technically, you can cross them, but what it tells you is your end behavior. So automatically, I know that as x approaches infinity, y approaches 0. As x approaches negative infinity, y approaches 0. That's what it's telling me. Okay, so we'll start with just drawing the lines. So now let's get some points. We have our 0 at 1, 0. So see what I said? You technically can cross the line, but you cannot, you can cross through the horizontal asymptote, and that's okay. All right, so we've got our 0 at 1, 0. Now let's get our y-intercept at 0, 1, 6. Okay, so somewhere around there. Okay, so we have these points. Now, I said that this is a complicated one, and it is. They are not all this complicated. So to solve this, I'm going to go back down to my factored terms, okay? So I'll come down here, and I know I have x minus 1 over x minus 3, x plus 2. All right, and now to figure out what is happening in this graph, I'm going to plug in a couple points. Now, it's not so important what the exact point is. What we want to know is it positive or is it negative? Okay, so is it positive or negative? So let's start with x equals 2. So if I plug in x equals 2, well, 2 minus 1 is a positive number. 2 minus 3 is negative. 2 plus 2 is positive. So if I multiply these two, I have a positive divided by a negative, which is negative. Okay? So if I plug in 2, I have a negative number in my y value. Okay? So that helps me to know the direction. So if I'm to the left side here, remember, I can't cross that asymptote. I can get infinitely close to it, but I cannot cross it. Okay, I can't even touch it. Now, we just saw that if I plug in positive 2, I'm going to get a negative y. So it's going to come like this. Now, how do I know it's not going to cross that x-axis again? Well, there are no other zeros. The only place it can cross or touch the x-axis is at our zeros. So it's either going to, I have two options. It's either going to bounce like this, or it's going to cross through. So that's why I checked, if I plug in 2, is it positive or negative? So if it's positive, it would have bounced up. If it's negative, it passes through. So that's what we have. Okay, now one of the rules of rationals, and we'll be more specific next year when we do this, but as we step across, because we know it can't be equal to 3, x can't be equal to 3, but if I plug in values on the other side of 3, okay, typically rational functions, because to the left my graph is going down, Now on the right side, it's going to be going up. Okay, so they do opposite behaviors. And then over here, I know that as x gets infinitely large, y approaches 0. Y approaches 0. Okay? Now, same thing on the left side. So crossing over to our asymptote over here, where x is equal to -2. The same idea. So to the right of the asymptote, the graph is going up. So now to the left, it's going to be going down, opposite behavior. Okay? And then I have a graph that looks kind of like this. So if I asked what is the end behavior, as x approaches infinity, y approaches 0. As x approaches -infinity, so over here, y approaches 0. Okay? And again, I know this is really confusing. That's why I want you to take it step by step by step. If you get all the asymptotes in the right places, you have your zeros and you have your y-intercept correct, then you are going to earn about 90% of the points. So the rest of the graph is kind of trying to figure out, understanding what the rest of the graph looks like, but these are the important points right here. So let's try example 2 now. Okay, so again, we've gone through all this work, finding the domain, the hole, there is a hole in this case, the vertical asymptote, zeros. Okay, so now let's get the main information down. So I always like to start with the asymptotes, then I get zeros, intercepts, holes, and then I sketch the graph. Okay, so this time we have a vertical asymptote at x equals -1. Okay, so I've got my vertical asymptote, and then this time I have a horizontal asymptote at y equals 1. So it moved up a little bit. Okay, so you see those asymptotes shifted a bit here. Now now I've got asymptotes, now let's get the 0 and y-intercept. So I have a 0 at -2, 0, a y-intercept at 0, 2. And you will see that this graph is going to be significantly easier. When you have more than one vertical asymptote, it gets tricky because of that middle section that you have. So now, the basic graph of a rational function, if you remember, so a basic graph of a rational function looks kind of like this, remember? Okay, where you shift up, down, right, left, okay? And so this is basically what we have, okay? And how do I know where does this loop go? Does it come in quadrant 1 or does it come down here? How do we know? All right. Well, that's where my zeros and intercepts will really help. So I see that I have a graph here, and then, whoops, the other part of my graph is right here. Okay, and so that's the basic shape. But don't stop. Okay, we've got zeros, we got y-intercept, but there's still a hole. So what do we do? So I know that when x equals 2, there has to be a hole. So right here, there's a hole. Okay, because I know from my original function, x cannot be equal to 2. All right, so I show that by drawing a circle. So it's about right here, and you don't have to be super precise, just where x equals 0, I need to see a hole in the graph. So what that means is that if I were following my function, of course, I have what's called the discontinuity at the asymptote, so I have to pick up my pen, and now I jump across, and I have here. Now I have to pick up my pen again and then drop it down. Okay, that's called a discontinuity, but that's calculus for you. So here are 2 examples, and I'll send another video with another couple examples for you to see as well.